Alright friends, in this video we're going to discuss about containers. So this series was about compute section and we're going to actually talk about Kubernetes. But before we understand Kubernetes, I just wanted to cover containers. So if you're completely new to Kubernetes as well as containers, this will quickly give you an understanding of what containers are. Now for that, what I want you to look at is a simple development process, right? So let's say that there is a code given to this developer using this laptop. Time budget for that code is to be completed in 100 hours. This guy writes the code within 85 hours. Code is in his laptop, so till then, when this is 85 hours of work. From here, it goes to local server. He pushes over here, and their other colleagues of his are also contributing to the same application. So another 5 hours of tuning is required for maybe the code to work in sync with what others have written. Now from here, the code would go to the next area. Now, in a larger environment, a bigger team, and a bigger environment, you might see multiple such areas. I've kept it simple, 3 stages. But let's say this is the staging area, this is the pre-production area, and this is also the testing area. So, with a lot of stress test, lot of things happening on this, you might require that there are some changes required for it to work, and this might be the you know perfect update which you do, and then your code works kind of over here. Now, once the code is thorough and surely working over here, right, it would go to the production. Finally, when it goes to production, there would be no change. So until there's a change required, it will be still here, and here will be the final copy running. So maybe the original budget was 100 hours. The project got completed in 95 hours. Nothing like it, perfectly, done thing. Now, things change when, the demands change. In the sense is, let's say the development was to be done in Python, let's say 2.7. Now at that time, maybe that was something that was expected, that would be perfect for them to build a code on. Now after 6 months of period, right, it is now realized that 2.7 has some vulnerability. Now vulnerability may be with respect to some machine learning library or something which you are not using. But just because security team steps up and updates the production, because they are very clear that we don't want a support for 2.7, we now want only support 2.9 or 3.4 or whatever is the latest one now. So we only want that, and we only want that code to run over here. Now, since my environment is changing, right, there is no choice. The code has to come back over here and update itself to run in the new environment. Now, of course, it's not going to require 85 hours. The developer might just take another maybe 7 hours to update the code. But the catch is, right, once the code is updated over here, so let's say this code is now updated over here, it goes back over here to the local server. Again, testing happens over here. So this again will require some hours of effort, so maybe 2 hours, because others have also updated their respective codes. And then would go to the staging area again. Maybe you may spend another 3 hours or whatever required for it, and then it will again come back to production. Now at the start of this, it was appearing that we did more than well. 100 hours of budget and finished in 95 hours. Now if you see, we have overshot the overall budget by 7 hours. Context was very simple, right, to bring up that this was a problem which industry was facing, right? So constant need to upgrade, and environments keep changing. With updates, environment needs to be uh, updated. Environment moment is updated, code also has to be updated with it. So that continuous problem was there in updating the and making the code work on the current whatever is the language and the support required for it. So that environment had to be constantly updated. So to solve this problem, right, what was done was, if we can run this code instead of directly inside this VM in a isolated environment. Okay, so the idea was, if we can run this in the isolated environment, it doesn't matter what is running over here in this VM. If this goes to this server, it doesn't matter what background or what services are running over here, because it is carrying its libraries, it is carrying its dependencies, and it is running in isolation. So with this capability, right, code could run wherever it go in the same fashion. And this is the idea which was brought in by containerization. Now just imagine that you want to run the uh, same application but in different versions of it, right? It's very difficult to run it in a single machine. Like say I want to run, uh, two offices, two MS Office in the same laptop, both of different versions. It would clash, kind of, they will try to use the same DLL files. Now, context is that any application, right, when running in an OS, requires some amount of dependencies, requires some amount of files from the system. And the context over here is all the dependencies of the application, all the library files which are required for it are kept in isolation. So they don't conflict with other containers which are there. And this was the beauty of containerization. So once you build a container will run the way it is in wherever it goes. Now, to expand a bit on this context of containers, right? How we compare that to virtual machines. Now, if you look at virtual machines require some of the other physical hypervisor server to run. So is containers, but containers are agile. They can either work on a VM or a physical box. It depends upon how we configure. Rather, in the cloud, you will see majorly containers running on the VM because cloud environments are tuned to work with virtual machines, and that's why most of the containers are today deployed as in virtual machines. Each container will have some amount of resource requirement depending on what application is built in inside it. You can define specific quota for it. So each container will have its CPU, have its memory allocation, it have the application code allocated for it or compiled along with it, and will run as a service from that VM. So how many containers you can run in a VM? Well, that depends upon what amount of resource the container is and what amount of resource the virtual machine or the physical server can offer. No such restrictions from containerization from as such. Now, just to set up the context, if you have worked a lot with virtual machines, right, this becomes easy to understand. So, in terms of analogy, right, to understand that if you look at virtual machine, right, in containerization world, we will call this as a container. Now, generally, virtual machines run on some of the other hypervisor, right? So we have uh, KVM, Hyper-V, VMware ESXi hypervisor, right? So ESXi, quite a few of them are there, right? So this requires a Docker daemon service, right, which is actually running and which gives the runtime for the container to come up, right? So that's a Docker daemon, which is the engine running for it. That's your Docker. It, and to manage containers, right, or rather, sorry, to manage virtual machines, right, you have a lot of virtual management tools available in the industry. So if you're using ESXi, right, you might be using System Center for managing your VMs, right? Uh, so that's another tool. Now, if you're doing with Microsoft, then they also have their tool for it, System Center Manager or something is there. Some sort of CCM name is there for it. Some of the other control plane management tool which is required for it, right? Same way, containers are also require some management tools, and these are going to be, like your uh, Kubernetes, which is very popular. Your Kubernetes, we have uh, Docker Swarm, right? AWS offers ECS and EKS both as managed service. That's managed Kubernetes. And same way, your Google also has in GCP our Kubernetes service for it. So Kubernetes engine is the name of service for it. It's a managed Kubernetes. Okay. So that's a bit of an abstraction to understand what containers are. So this was a quick video. Do let me know in the comments if you have any doubts about it. Thank you.